Perimeter and area of composite figures with Pythagorean theorem, question 1b. So taking a look at this shape, we want to find both the perimeter and the area of this. It's a rather unusual looking shape, and it's definitely not one of the shapes on my formula sheet. But I do think it's probably a combination of some of the shapes that we have on this sheet. So looking at this picture, I do see that there's a curved edge, which makes me think there's definitely a part of a circle in here, and then there are some straight sides. So I'm going to try to isolate where I think that curve stops, which is somewhere up here. I think this is a piece of a circle with a triangle stuck on the end. How much of a circle? If you were to draw in the full circle, I think that that is 1/4 of a circle. So I think this is 1/4 of a circle and a triangle added together. So I'm going to maybe write that at the bottom to remind myself. Okay, so if we start with perimeter, to calculate perimeter, all you need to do is add up all of your edges. Now, this is tricky because some of them are curved. So I would consider that there are 1, 2, 3 straight edges and then 1 curved edge for a grand total of 4 sides or 4 edges that we're adding together. Now, of those, I know 1, 2 of them. So I'm going to have to figure out this straight side up here and the curved edge as well. And there is a little bit of space here for us to find a missing dimension, and we're going to have to see how this goes. So I do notice in the triangle that it is a right angle triangle, the way I've drawn it. So I should be able to use Pythagorean theorem to find this side here, but that would mean I'd need to know that side there. And there is a trick to that. So this I treated as the center of my circle. So the distance from the center of the circle to the edge is the radius, which means the radius is the same in all directions around the circle, which means this side here should also be 100 millimeters because it's just the radius of the circle drawn in a different section of the circle. So if I know that this is 100 and this is 12, something about that doesn't seem quite right. How is this side 100 and this side is only 12? Well, I don't know if you noticed, but the units don't match. So I have a choice. I can either change millimeters into centimeters or centimeters into millimeters. And since I already have 2 things written down that are in millimeters, I think I'm going to try to change the centimeters. So if we are converting from centimeters into millimeters, I'm going to look at my conversion sheet that we did. So to go from centimeters to millimeters, I am moving down 1 step. When we move down, we move the decimal to the right. So I'm going to move the decimal on the 12 centimeters, which is currently after the 2, 1 step to the right. Now there aren't any numbers there, so I'm going to add in a little 0 to get that this is 120 millimeters. Okay, so now that they're in the same unit, I'm going to attempt to use Pythagorean theorem to find this missing side up here. I'm going to maybe call that x for right now. So if I label my sides, the hypotenuse is always the one across from the right angle. So that's going to make this side C. And then A and B, it doesn't really matter. I think I might like this one A and this one B. So in the space for missing dimensions, I'm going to do a squared plus b squared equals c squared. So x squared plus 100 squared equals 120 squared. 100 squared is 10,000. I'm just going to check that. So that's 10,000. And then 120 squared, that's 120 times 120, which is 14,400. All right, so if I want to solve for x, I need to start by subtracting 10,000. It's a lot of zeros. So x squared equals 14,400 minus 10,000 is 4,400. And then I want to cancel out that square by doing the square root. So the square root of 4,400 is 66.33. I want to keep 2 decimal places. I'm going to take a peek at the next number, which is a 2, which means we're going to leave it as 33. So if that number had been a 5, 6, 7, 8, or 9, I would round it up. But since it's only a 2, we're going to leave it at 66.33. So that means x is approximately 66.33 millimeters. If you were doing this in centimeters, it would have been 6.63 centimeters. So I now know that this section here is 66.33 millimeters. And then that just leaves me with the curved edge. Now we said this is approximately 1/4 of a circle. So to find the perimeter of a circle, the perimeter of a circle is called the circumference. And I can either use the formula pi times d, pi times the diameter, or 2 pi r. Now, this distance, 100 millimeters, is the radius. It doesn't go all the way across, so I think I'm going to use 2 pi r. So still in this box, I'm going to write circumference is 2 pi r, except we don't want the whole circle. We only want 1/4 of the circle. So I'm going to take that circumference and divide it by 4. So circumference is 2 times pi. I'm going to wait and use my pi button. If you don't have a pi button, you can use 3.14159 times my radius, which is 100, and then divided by 4. So I'm going to calculate that on my calculator. So I'm going to do 2 times, and then I'm going to use my pi button, or like I said, 3.14159. You won't get exactly the same answer, but it'll be close. And then times 100, and then divided by 4. And I get 157.07. And then the next number is a 9, so that's going to push that up to 0.8. So 157.08. And that is also millimeters. Okay, so I think we're now ready to calculate the perimeter. I now know all 4 of my outside edges. So my perimeter is going to equal, now I like to make up a formula. I've already used A, B, and C, so I think like last time I'm going to pick some different letters that we haven't used yet. So maybe W, X, Y, and Z again. Since this is already X, maybe I'll call this W, X, Y, and Z. So my perimeter is W plus X plus Y plus Z. I just need 4 letters to show that there are 4 sides. And then I'm going to add 157.08 plus 66.33 plus 120 plus 100. Okay. So 157.08 plus 66.33 plus 120 plus 100 gives me a grand total of 443.41. So 443.41 millimeters. If you did it in centimeters, it would have been 44.34 centimeters, but we chose to do millimeters. All right, the last part is the area. So when I'm doing area, I have to break it down into shapes that I can find on my formula sheet. So with perimeter, we just add our sides together, but when we're doing area, we have to break it down into shapes. So I definitely have a triangle and a circle. So we have 1/4 of a circle, and we have an entire triangle. So I think I might start with the circle. Maybe I'll call that part 1, this one part 2. So the area of my circle, sometimes instead of labeling 1 and 2, I could write circle, and then triangle and break it up that way. We just want to find a way to organize our solution. So the area of a circle, according to our formula sheet, is pi r squared. So area is pi r squared, but it is not a full circle. It is only a quarter of a circle. So I'm going to divide that by 4. So pi, I'm going to use my pi button. The radius, we already said, was 100. And if I'm squaring that, I'm just going to write it as multiplying it by itself, save myself a step, and then divide by 4. So pi times 100 times 100 divided by 4 gives me 7,853.98. I take a peek at the next number. It's a 1, so it's going to stay 0.98. So 7,853.98. And that should be millimeters squared because it's area, and approximate because I rounded. Okay, so then I'm going to do the triangle. So the area of a triangle is base times height divided by 2, or 1/2 base height, which I don't really like. So base times height divided by 2. So I'm going to take a look at my picture and figure out where is the base and where is the height. This is tricky. So on my formula sheet, the triangle that's here and the triangle that's here don't exactly look the same. But the base and the height of a triangle will always meet at 90 degrees. So in my triangle, I have a 90-degree angle right there, which means one of these is the base and one of these is the height. So sometimes it helps if you just turn your page and look at it from a different perspective, right? If I look at it this way, it looks a little more like this could be the base and this could be the height. Or you can turn it this way, and then this would be the base and this would be the height. So it is really your choice, but one of these is the base and one of them is the height in your triangle because they meet at 90 degrees. That's how I know where the base and the height are, even though it doesn't exactly look like the picture on the formula sheet. So when I go to do my area, base and height, I didn't really specify which one was going to be which. I think I'm going to do 100 for the base and 66.33 for the height. You could switch them around, it wouldn't make a difference. And then that is divided by 2. So I'm going to calculate 100 times 66.33 and then divided by 2. And I get that it is 3,316.5 millimeters squared. Okay, so I've got the area of the circle, the area of the triangle. I'm going to add those two numbers together. And let's see what that gives us. So our total area is 7,853.98 plus 3,316.5 for a grand total of 11,170.48 millimeters squared. I did put the dot over top because we rounded the answers that we used when we got that calculation. All right, and that's it.